All right, we are looking at page 314, section 4.4, trig functions of any angle. And there on the top of the page, they give us the 6 trig functions that we already know and the definitions that we should already know. Sine is y over r, cosine is x over r, tangent is y over x, cosecant is r over y, secant is r over x, cotangent is x over y. Up until this point, however, every time we worked with those 6 trig functions, we were working with them in the first quadrant, so all of our answers were positive. It is possible, as you see in our diagram, for our triangle to be in an alternate quadrant, as it is here in the second quadrant, and in that case, x would be negative and y would be positive. So we want to look today at finding trig functions of any angle, not just in the first quadrant. Now we need to know where our 6 trig functions are positive and negative. You actually already know where your 6 trig functions are positive and negative. No, I don't. Yes, you do. The way that you already know is, remember that we've said in a unit circle, y is the same thing as sine, x is the same thing as cosine, and y over x is the same thing as tangent. So if I know where y is positive and negative, I know where sine is positive and negative, and I also know where cosecant is positive and negative. Because when we take sine and we find its reciprocal cosecant, if you take a positive number and flip it, you still have a positive number. If you take a negative number and flip it, you still have a negative number. So y, sine, and cosecant will all have the same sign. X, cosine, and secant will all have the same sign. And if I take y and divide it by x, that will be my tangent and cotangent. So let's start with y. When I'm looking at y in the first quadrant, y is positive. In the second quadrant, y is positive. In the third quadrant, y is negative. And in the fourth quadrant, y is negative. So that means that in the first quadrant, sine and cosecant are positive. In the second quadrant, sine and cosecant are positive. Third quadrant, they're negative. Fourth quadrant, they're negative. All right, let's do the same thing with x. In the first quadrant, x is positive. In the second quadrant, x is negative. In the third quadrant, x is negative. And in the fourth quadrant, x is positive. So that means that x, cosine, and secant are all positive in the first, negative in the second, negative in the third, and positive in the fourth. To find tangent and cotangent, we take our y value and divide it by our x value. So we can say, okay, let's take a positive and divide it by a positive. That would be a positive. Second quadrant, positive divided by negative would be a negative. Third quadrant, negative divided by negative would be a positive. Fourth quadrant, negative divided by a positive would be a negative. So it doesn't take us very long to build this entire chart. We want to memorize tonight where all 6 of our trig functions are positive and negative. If you were going to answer 20 questions on a test, you probably would want to take the time to build this chart. But if you just were trying to answer 1 or 2 questions, it'd be nice if we had a fast, easy way to remember where our functions are positive and negative. The way that we can do that is with a little mnemonic device. All students take calculus. It's very similar to using Please Excuse My Dear Aunt Sally to help us remember order of operations. If I use the first letters A, S, T, C, A is in the first quadrant, S in the second, T in the third, C in the fourth, that reminds me that in the first quadrant, all of our 3 trig functions, sine, cosine, and tangent, are positive. Now notice that I said 3 because, of course, when we invert them, we get the exact same sign. In the second quadrant, out of our 3 main trig functions, only sine is positive. So, of course, we're not saying that cosecant is negative when we say that only sine is positive. We're saying that out of the 3 main trig functions, sine, and therefore, by association, its reciprocal, are positive. In the third quadrant, T means that only tangent is positive, and in the fourth quadrant, C means only cosine is positive. So ASTC tells me what is positive in what quadrant. All in the first, only sine in the second, only tangent in the third, only cosine in the fourth. Now, we've talked about the inside of the unit circle and how to create those values. Today we want to look at how to find the values on the outside of the unit circle. And I know that looks like a lot of memorization, so what I want to show you is the pattern of the circle. If you'll notice, the first line in every quadrant that is closest to the x-axis, it's going to be a multiple of pi over 6, meaning it has a pi over 6 in it. Every one of those has the exact same ordered pair, square root of 3 over 2 1/2. Here's another one. The first line closest to the x-axis has a pi over 6 in it. Same ordered pair, square root of 3 over 2 1/2. Down here, the first line closest to the x-axis has a pi over 6 in it. Ordered pair is square root of 3 over 2 1/2. Over here, first line closest to the x-axis has a pi over 6 in it. Ordered pair, square root of 3 over 2 1/2. Now, I realize that the positives and the negatives are changing. We'll come back and deal with that in just a minute. All right, look at the second pair. At the middle line in every one of our quadrants, we'll have something that has a pi over 4 in it. So 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Notice that every one of those have the exact same ordered pair, square root of 2 over 2, square root of 2 over 2. Again, the positives and negatives change, but we'll address that in a minute. The third one, which is the line that is furthest away from the x-axis, each of these are going to have a pi over 3 in them. So 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. For each of those, you'll notice they have the exact same ordered pair, 1/2 square root of 3 over 2 for each of these. All right, so once I see that pattern on my circle, to figure out where the positives and negatives come from, I go back to that same thing that we were just talking about with the All Students Take Calculus. In the first quadrant, all of them are positive. In the second quadrant, only sine is positive, so cosine is negative. In the third quadrant, only tangent is positive, so sine and cosine are both negative. And in the fourth quadrant, C, only cosine is positive, so sine is negative. Since cosine is the same thing as x and sine is the same thing as y, then that means in the first quadrant, both x and y values, both sine and cosine values, should be positive. And so sure enough, if you look at every single one of these values, they're all positive. In the second quadrant, the cosine x value should be negative, the sine y value should be positive. And so in every one of these ordered pairs, notice that the x value, the cosine, is negative, and notice that the sine, the y value, is positive. In the third quadrant, they should both be negative, and absolutely every one of them is negative. And in the fourth quadrant, the cosine x value should be positive, the sine y value should be negative, and notice every one of these cosine x values positive, every one of these sine y values negative. So now that makes understanding and remembering the outside of the unit circle so much simpler. We don't seem to have any trouble once we know that pattern of taking the square root of 3 over 2 1/2 and moving it around the circle to the other places. But how do I remember those 6 values in the first quadrant? Well, I can first off use common sense. If you'll notice, the middle pair, square root of 2 over 2, square root of 2 over 2, since it's the same and it's the middle one, it's pretty easy to keep straight. You'll also notice that in the other two pairs, square root of 3 over 2 1/2, square root of 3 over 2 1/2, 1/2 square root of 3 over 2, notice that the values are the same, square root of 3 over 2 and 1/2. It's just the order that changes. So that tends to be the most confusing thing for students. They can't remember which comes first, square root of 3 over 2 or 1/2. Remember that this is still an ordered pair plotted point. Square root of 3 over 2, if you put that in your calculator, is 0.866. That's approximately 0.9. So if I take this point and I bring it straight down to trace down its x value, and I bring it straight over to trace its y value, I'm looking at this going, okay, bring it straight down. That x value, if I'm trying to figure out, is that 1/2 or square root of 3 over 2? Well, that's really close to this value of 1 right here. 1/2 would be way back here, so that's got to be square root of 3 over 2. Whereas if I trace it straight over, you can see that's about halfway up that line from 0 to 1. So it makes sense then why the y value is 1/2, because square root of 3 over 2 would have to be way up here. Similarly, if I look at this ordered pair, 1/2 square root of 3 over 2, if I take the x value and I trace it straight down, that looks like it's about halfway down that line, so that's why x is 1/2. If I take it and trace it straight over to the y-axis, I see that I'm about at 0.9, so that's why the y value is 0.9, or square root of 3 over 2. Another really practical way of remembering this is to notice the numerators. If you'll notice, if I start down here with 0, my numerators are going to count up. 0, 1, 2, 3. Happens the same way on the inside. If I start right here at 0, my numerators are going to count up. So 0, 1, 2, 3. And so that gives me an easy way to remember that first quadrant. Because if I'm trying to draw that first quadrant, so I've got my 3 lines here, and each of them is going to have an ordered pair, I know that the ordered pair here is 1, 0. I know the ordered pair here is 0, 1, so I can go through and say, starting with 0, 0, 1, 2, 3, and starting here with 0, 0, 1, 2, 3. The only thing I have that has a 1 in the numerator out of that 1/2 square root of 3 over 2 and square root of 2 over 2 is 1/2. So that tells me what those are. The only one that has a 3 in the numerator is square root of 3 over 2. So that tells me what these are. And the only one that I have that has a 2 in it is square root of 2 over 2. So that tells me what these are. So that is the fastest, easiest, most practical way that I know of building that first quadrant. And of course, once you have the first quadrant, we don't have any trouble moving it to the exact same ordered pairs in the other quadrants. All right, so now that we've got some background on the unit circle and how to create those values, let's look at example number 1. For example number 1, they give me an ordered pair, negative 3, 4, and they say, let negative 3, 4 be a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. All right, can I automatically assume that sine is equal to 4 and cosine is equal to negative 3? Well, if that were the case, I would have to be working with a unit circle. What's a unit circle? Remember, that's the circle with the radius of 1. Well, does this circle have a radius of 1? Absolutely not. You can't have a radius of 1 if your x and y values are larger than 1. Remember, your radius, your hypotenuse, has to be the largest value. This is not a unit circle. Sine does not equal y, cosine does not equal x then. I need to go back to these 6 definitions on the top of the page. This is, however, a 3, 4, 5 triangle. So you'll notice that if x was negative 3 and y is positive 4, then I would know that my radius is 5. If I didn't happen to remember that, I could always use Pythagorean Theorem and do a squared plus b squared is equal to c squared. Now, if I do Pythagorean Theorem, I'm going to get down here to r squared equals 25, take the square root of both sides, and I'll get r is equal to either a positive or a negative 5. So which one is it? Is it positive or negative? Well, this is a radius. A radius is a distance. It's a length. It can't be negative, so I know that that's got to be a positive 5. Additionally, then I can go through and I can find sine, cosine, and tangent by using my definitions. So sine by definition was y over r. So if I take my y value 4 and I put it over my r value 5, then sine is going to be 4/5. Cosine is x over r. So I'll take my x value negative 3, put it over my r value of 5, and I'll get negative 3/5. Tangent is y over x. So I'll take my y value 4 and put it over my x value negative 3, and I'll get 4 over negative 3, or negative 4/3. All right, look at example 2. For example 2, it says, given tangent theta is equal to negative 5/4 and cosine is greater than 0, find sine and secant. All right, so I start off by saying if tangent is y over x, then I know that 5 has to be y and 4 has to be x. The only problem is one of those is negative, and I don't know which one it is. Is it negative 5 over positive 4, or is it positive 5 over negative